Next, we're going to look at page 2. And what we have there is the same reaction that's just copied from page 1. So that first set of circles, I'll just highlight these and then I'll erase it. But that portion right there is the H2 that we saw on the previous page. That molecule right there is the O2, and we're making water. Notice again that we just have one representative particle of each reactant to make one representative particle of the product. So that correctly tells us that hydrogen reacts with oxygen to make water. What it doesn't tell us is how many hydrogen molecules we need, or how many oxygen molecules we need to make how many molecules of water. That's the process of balancing that we want to look at now. So let me just erase that. Sometimes you can just inspect the diagrams to figure it out. I'm going to overlay a little bit of chemist algorithm to do this. So I'm going to inventory the atoms on the left and right sides, being the reactant and the product sides. And here it just appears as circles, but remember, this is a continuation of the previous page, so I know that those small white circles are H's. There are 2 of them on the left, or the reactant side. Those shaded circles are oxygen. There are 2 of them on the left. And then it's the same type of atoms on the right-hand side, right? Because we can't make new types of atoms during a chemical reaction. A chemical reaction is just a rearrangement of the atoms. But I have 2 hydrogen and 1 oxygen. Okay, so it appears that while we have the same number of hydrogen on each side of the reaction, we have different numbers of oxygen. So what when students are first learning this, they might say something like, oh, I just need to add an oxygen. So I'm going to do that. It's going to be not good thinking, but I'm just going to add an oxygen there and say, oh, that must do it. The problem with that is that singular atoms of oxygen aren't part of the products. That they don't exist that way. As an element, they're O2, and here what we're making is water. So I'm going to erase that, and instead I'm going to recognize that if I want to add more oxygen on the right side, I need to do it as part of a water molecule. So I'm going to copy that water molecule. It very nicely duplicates it for me. I think I can move it. So now I have 2 water molecules on the right-hand side. So I now need to update my count of atoms. I have 4 hydrogen now. I have 4 of those small white circles. And I do indeed have 2 oxygen. So now I look at that and I say, okay, I've got the oxygen atoms balanced, but when doing that, I brought the hydrogen atoms out of balance. So it looks like I need more hydrogen atoms on the left-hand side. So what I then do is I can't just add separate little circles because the hydrogen comes in packets of H2 molecules. So I just need another H2 molecule. So I'm going to copy this, instantly paste. I'll move it to make it look better. And there we go. And now I'll update the count on that side. And I think that gives me the pin. And I now have 4 hydrogen atoms on the left-hand side and the 2 oxygen atoms. So, well, this is fantastic because now my type and number of atoms on the left and the right are the same. So number 2 said, draw additional molecules on the reactant and product sides until the same number of each type of atom is present. After all, we cannot create or destroy atoms, so we've clearly done that. I'll put a check mark there. Now the last part of this is to turn our drawing into official chemistry language. And so the first part here, we have hydrogen molecules. They are H2. But we have 2 of them. That's why we do 2H2, so to speak. We don't write H subscript 4, and we don't write 4 H's because that's not how it's presented. In this drawing up top here, we have 2 H2s. And then we have 1 O2, for which we can just write O2. And then we have to write what this is here. So how does the chemist use proper notation to write what that is? Well, each one of those is an H2O, and we happen to have 2 of them. So they are H2O, and you have 2 of them. So that now is the proper notation for the balanced chemical equation. That's what we're looking for you to do on your quiz.